move to the last session of the day, which is a much awaited keynote address by Mr. Srinivas Lingam. And this is about AI at population scale. With about 1.4 billion people, India faces significant logistical and interoperability challenges when implementing any technology solution across its many states and vast population. But this challenge also poses a significant opportunity to solve difficult problems at a scale large enough for the solution to be applicable worldwide. The keynote titled AI at Population Scale will talk about many of these aspects and more. It is my pleasure to introduce Mr. Srinivas Lingam, VP Data Platform Group and GM, AI Product Group, Intel India. Mr. Srinivas has overall responsibility for developing deep learning training and inference products to Intel's data center and cloud customers. He has built the Artificial Intelligence Group in India since 2016 and led the organization into a deep learning center of excellence with end-to-end capabilities. His team delivered Intel's first data center inference accelerator and won Intel Achievement Award. Srinivas joined Intel in 1997 as a design engineer on a CPU development team based in California. During his nearly 25 years of experience at Intel, he led the CPU design, SoC, chipset, soft IP, hard IP, and AI teams across United States, Israel, Malaysia, India, and Costa Rica. Srinivas holds a master's degree in electrical and computer engineering from the University of Florida, Gainesville, and MBA degree from the University of California, Davis. With that, welcome, Mr. Srinivas Lingam.
Thank you. I can start presentation, I guess, right?
Sure.
Sorry, I should have started. Let me know when you can see.
We can see, you can put in the presentation mode.
Okay, thanks for the warm introduction, Kamal. I know I'm the last, and hopefully I still have audience to pay attention to one of the most interesting topic for all of us in India to get AI to the population scale. Let me first give my opinion of where AI is in the big scheme of things. I know it's a IPL season, so I'm going to use an example that is not related to IPL. But if AI is a test match, in my opinion, we are barely in the first day of the test match, for 1 or 2 sessions in the test match. There's a lot of work ahead of us, and AI touches every aspect of the life, and the opportunities are immense. So for those of you who are thinking that AI is advanced and potentially we are missing the boat or something like that, my personal belief and belief of many experts is we have a long way to go. And now we need to make sure this AI not only just touches all the industrial applications involved. Yeah.
Sorry to stop you. Your presentation is actually coming half. Your speaker notes are visible. So if you want to change that would be great. Thank you.
So let me try to just share again, just 1 second. Give me a second if you don't mind. Where do I share here? Share screen. There's an option to share screen, right? Okay.
I think you did something which was okay after that. Yeah, now it's okay. Great.
Can you see what I'm sharing?
Yes, this is good. Thank you.
Okay.
We can see your presentation.
Yeah, I have a problem on my side. Just give me 10 seconds, please.
Sure.
You can still see my presentation, or
yes,
the split screen?
Yeah, okay. I can see your slide where the cricket thing is there.
Okay, sorry. My point here is that there's a long ways to go for AI, and they're still in the early innings of this game. So let me move forward. Let's first talk about the AI opportunity for India. right? We have seen AI to make big economic impact in several areas like search and recommendation engine, voice bots, and targeted advertisements and many things. But one of the areas, the real application of AI beyond these commercial uses is to have its influence on the healthcare, the smart mobility, the industrial 4.0, agricultural, and financial services. I mean, what is very heartening for me is it's not just some of us in the industry trying to thrive for this. India is looking at it very carefully, and they're following a similar approach with NITI publishing the national strategy paper, AI for All. We worked very closely with them and collaborated with them on the strategy and direction. So this is an opportunity for India to lead the world and showing how AI can really help take care of the humans beyond the commercial usages of AI, and help societies in an inclusive manner, not in some kind of weaponized manner, but more inclusive manner to make AI reach the broader population. Like I said, where the opportunity is immense and AI will go almost to all areas of life, we need to pivot and look at AI from the human-centric area and from focus on more of a human-centered AI. And to address this, the next step is to see what are some of the national level problems and what we can deal with AI and what are the requirements. Right? AI can solve needs of India, that's very clear, but we need significant focus on 4 different vectors to make it happen. One is the talent, very clear. The next one is the technology and IP. The next one is on the policy, and 4th one is on data. Let's talk talent. Today, from the world talent point of view, 16% of the world's AI talent is coming from the United States. Around 9 or 10% is coming from China. And India is in good shape. We have about 8% of the world's AI talent being supplied by India. So we are in a good shape, but we should try to, with our population and our capability, we should try to take this to 20s or 30% over years. The second thing is technology and IP. Do you have access to technology? Right? Have you created enough IP? I mean, there are lots of patents being filed and IP being generated. For example, China took a big leap. They have like 40% of the world IP in the recent years is coming from China, and about 20-25% from the US, and Japan is at the 3rd place, 14%. So we need to focus on this technology as well. And the third one is, are we leveraging the policies and regulations to make sure that these technologies are used for the good of the humanity? I mean, do we have robust policy environment? Do we need regulatory help? So these are the areas we need to focus on as we scale AI to the population scale. And the last and one of the most important is the data. I mean, data is being generated in tons, right? Like any number we here is like 175 zettabytes of data will be there by 2025. It's mind-boggling number. We need to make sure this data is secure, this data is accessible and rich. So to do that, we need a few drivers. We need to make investments across the board. And while India is making bold moves, our investment in this field of AI is about 5%. I mean, like I said, China in this area again is leading the pack with nearly 60% of the world's AI investment in the recent years. China just doubled down on this, and US is obviously making big investments, about 30% or so. India is doing okay, but we can probably enhance more. But let us focus on the key drivers that we need to pay attention to while we invest on all these 4 vectors. We need to build AI experts. That's first and foremost. And today we are about, like I said, 8% of the talent, but we need to increase the expertise on AI. And we need to amp our research output, right, to generate indigenous IP that is localized and help our local ecosystem. And we need to ensure we have the policy regime and a sandbox to test new technologies like AI, and make sure it is meeting the security and privacy and ethics and all other aspects of the policy. And finally, on the data side, we will need curated, annotated data to ensure we develop and deploy the correct AI solutions. I mean, this needs enabling across the board from different technology pillars, from platform for training, from compute, from software and hardware architecture solutions, safe and secure privacy protection technology, of course, the cloud and edge. So we need to fire on all cylinders to be able to realize our dream of addressing the national problems using AI. Now, I want to talk a little bit on the first two pillars I talked in terms of talent and technology IP. I mean, one of the ways to meet the population scale demand is to leverage on technology-led disruptions. I mean, if you look at the last 40 years, we have seen some amazing technology-led disruptions when we made a lot of performance available to a lot of people. I mean, the keyword here is a lot of technology, a lot of performance available to a lot of people. I mean, in the PC era, we digitized everything we could and we networked everything we could. In the end, we got 1 billion people onto the internet, and it changed the way we learn and the way we work and the way we entertain ourselves. So this is not new. These technology-led disruptions are population scale. I mean, in the next disruption was the mobile and cloud era that we all are aware of, where we have 10 billion mobile devices connected to supercomputers in the world. And that changed everything. Even more so, we can feel its power in this, in this pandemic phase we are in, where this touches every human being, and we thought that life would have been even more difficult than it is already today. Now, what is the next disruption going to be? In my opinion, and in the opinion of several experts, the next disruption will be to go to 100 billion devices that are connected and intelligent, right? It helps protecting and enriching our lives more than the ways we can imagine. If the first two disruptions are earth-shattering, I think the new disruption that we are entering into is going to be even more world-changing. Intelligence will require a ton of computing, I mean, from exascale and beyond, computing that should be equally accessible to anyone and everyone, right? It should be like, free from wherever the data resides, we should be able to access it from anywhere in the world. And it's not just controlled by the few big companies or few big proprietary abstractions and all those things. It's an exascale computing that should be accessible to everyone like it's electricity today. So that should be the Uber goal for all of us. And this is the future that really excites me and many of my colleagues. I mean, it's like 10x of the industry expansion, and it can touch every human being. So in the coming few slides, let me talk a little bit of where these computing demands are coming from before we understand how to reach to the population scale AI. The biggest place where this computing demand is coming from is, of course, the data is exploding. Right? The key breakthrough in the recent decade is how we are collecting data. I mean, as you can see in the graph here, by 2025, we'll be having 175 zettabytes of data. For those of you who are not keeping up with these code, zeta is like 10 to the power 21 zeros, right? But they're just generating a lot of data. Are we leveraging it properly, right? Are we leveraging the data to build our intelligence? But as a world, we are generating a ton of data, but I don't think we have the ability to analyze and understand. I mean, this data is not only stressing on the need for more compute, but it also stresses the whole infrastructure. I mean, we need to have more capacity. We need to have more bandwidth at every level of the memory hierarchy. And we need to network. We need our networks to handle this data. And a lot of things ride on this exploding of data. That's the first challenge that is leading to the compute exploding that I talked about. The next one is the second challenge we're facing today is that the complexity of these deep learning models are growing in an exponential rate. I mean, the data I'm showing here is from June of 2020. The y-axis shows the number of model parameters. In some sense, it's a representation of the complexity of the model of the neural network. And the y-axis is the timeline. As you can see in February 2020, what you see here is like we had about, OpenAI came up with GPT-2, which has about 1.5 billion parameters. And then we have as much as 17 billion parameters models. These models are exploding, but that's just the beginning. And these are continuing to grow. Just the same OpenAI-based GPT-2, the GPT-3 is about 175 billion parameters. You're talking just in 18 months, it's 100x growth in the complexity on a given model. And this trend seems to be continuing too much, right? It's too complex, but this trend is too complex to continue. We cannot sustain this trend. So what do we do about it? I mean, before I talk about what we can do about it and how to make, I mean, this is actually alarming. This tells us that as the compute and demands are growing and our uber goal of trying to get AI to the population scale, they can be at odds, because this can be only accessed by few if the compute demands are so high. But before I go into the growing compute demand, I'm sure many of you are aware of the good old times. Good old times is not that far ago. It's prior to 2010 and such, where the Moore's law was thriving, and the compute is doubling every 2 years, and life was good. I mean, whatever the hardware comes up with a new cool feature, the software takes advantage of it and comes with even more powerful programs, and then the hardware catches up. So we used to call it Intel as this as a software spiral, right? So this was going well till 2010 timeframe, but then came the revolution of deep learning, and it's no longer a two-dimensional linear equation. Now it's a three-dimensional equation, right? Life becomes complex with bigger models. These bigger models are driving need for bigger data, and this bigger data is driving more compute, and the more compute enables bigger models. So this software triangle is continuing, and the deep neural network models are increasing in complexity, and that is putting a huge pressure in compute. Now the compute demand is like double every 3 to 4 months. If you think about it, it's 10x computing power demand in a year, right? And this is definitely not sustainable. I just want to impress on how things are going and how complex things are getting. But we have a challenge of trying to get AI to the population scale. If you can see in the chart in the bottom, this is not affordable to meet the population scale if this is the compute demand. And it's also not sustainable, if nothing else, for the carbon footprint and the carbon emissions point of view. See this graph where it's charting the carbon emissions. Interesting study that shows to manufacture a US car and to run it for its entire lifetime versus training a AI model, it takes 5x the carbon emission just to train an AI model. And this data is from 2019, and add 10x to it, and it's just getting out of control. The point here is, back to my original analogy where I talked about, we are in the first innings of the first day of the test match. Things are still, there's a lot of ways to go before we can tame AI to go from, becoming unsustainable to sustainable to affordable to take it to the population scale. But we need to work towards it to be able to realize this dream. So I just want to show these technology trends before I get into how we scale it back to the population scale. Now, we talked about all these data explosion, the model explosion, and the compute explosion, and all those things. But let me talk about one real life example. This is a real life customer example for a defect detection. In the production deployment, beyond just AI, you see here, there's a bunch of other activities that go into the production. I mean, like deploying the model, the data preparation, and the data processing, the decision processing post AI phase, the broader application and refreshing the data. So there's a bunch of things that are outside the quote unquote, pure AI that we talk about, right? If you zoom into the AI step one click, even within the AI step, before we infer something, we need to train. And this training phase also involves a lot of things that are just not pure compute intensive things like, experimenting with topologies and tuning hyperparameters. These are the classic AI and deep learning activities. These are not the only things that exist in this pie. There are things like labeling data, loading data, augmenting data, right? And, and after the fact, supporting the inference inputs and, doing many post-processing that are labor intensive. My point here is there are several adjacencies outside the core AI that we talked about that we need to be prepared if we want to take AI to the population scale, right? These adjacency disciplines, if we work on it, we can make AI to work for us really well. And if we invest in these adjacencies in the form of data and algorithms and processes to deploy it at scale and maintain the solution to stay current, we can definitely grow our AI workforce from our existing 8-9% of the world's workforce to, like I said, 20-30% over years. So we have to pay attention to not just get caught up in the AI, but all the adjacencies around AI to make it happen. Now, we are not just talking the talk at Intel and many other corporations in India and other research institutions and government. We are creating some impact already with some of our ideas. It's very, let me build this slide. It's very clear we need to have the right data set. We need to have the right localized solutions that fit our local ecosystem. And we also need to reskill our people. Now, what we are doing in these respects is, from our viewpoints, I mean, we created Indian driving data set. It's a data set for India driving conditions to enable research in road safety and AI algorithms. That's one area. As Intel, we are contributing with other partners and the governments very well there. And also we are using our ADAS technology. We have conducted collision avoidance pilots in few cities, which have shown that solutions can, these collision avoidance solutions can reduce the near misses by 45 to 75%. So it's really exciting. There's a lot of potential to enrich human lives through these AI-driven initiatives. We have also been working to create scalable platforms and deploying AI-based solutions for healthcare in India. And last but not the least, we have AI for youth. We are working with the Ministry of Education to impact nearly 22,000 CBSE schools. I mean, we are partnering with the CBSE board, and we helped in curating and coming up with outcome-oriented AI curriculum. And as of date, we have reached out to nearly 200,000 students with this format. The summary is, we were able to create meaningful impact. I know there's a lot of road ahead of us and a lot of problems to solve, but we are not starting from zero. We have, embarked on in this journey ourselves, several partners in Indian ecosystem, the industry, the academia, the governments at varying levels of contributions. And we are able to create meaningful impact to these activities. I mean, this has also given us insights into how we can enable AI for the country. I mean, these experiments really help us, keep building how to make it AI for population scale. This is not only critical for national needs, but it also will help India accelerate our journey towards the $1 trillion digital economy we are talking about. So taking this experience that we built from our pilots and experiments we have been doing, I'm very happy to talk about what we did. I'm very happy to share that we formed in AI. It's basically an Indian AI Applied Research Center in collab for population scale AI. And it is done with collaboration with IIIT, Hyderabad, Government of Telangana, Public Health Foundation of India, and the Ministry of Science and Technology. I mean, this center is basically a distillation of all these learnings we collected over years. And we believe we have a blueprint for what it takes to do population scale AI. I'm sure we'll learn a lot, but at least we have a start point. To do AI at population scale, we need foundation to, we need to have a good annotated and curated data sets. We need to have open security data, and we need to have a way to exchange data. We need to have foundational AI technologies and algorithms and tools. All of this with keeping public good in mind. So to do that, we need to have a robust data governance in terms of privacy and security. So with this, I think we can definitely drive towards the goal of getting to AI at population scale. More importantly, we also need startups, the innovators, the researchers, the enterprises. We need all the platforms we have available at our disposal to propel this economic growth for the country, and thereby reaching AI to the masses. I mean, we cannot take everything in one shot. So our current focus is we will focus on deploying these public good assets in healthcare and smart mobility. Those are the two things, at least we in Intel India are collaborating with rest of the ecosystem partners and governments and researchers to drive this activity. And India has done really well with Aadhaar, with GST, with UPI. So it's time to show the world that we can deliver this human-centric AI at a population scale. I really think we can do it if we put our mind to it. And I'm really excited about that. Now, to conclude, I bring back the same slide I presented before. To address the national problems using AI, we need to have a parallel focus on all these 4 vectors we talked before. This includes the talent, the technology, the policy, and the data. On the talent side, like I said, we need to identify 3 or 4 problems and the skills needed to address those areas. We need to build AI solutions to impact them. Typically, the technology adoption can sometimes take a lot of time, 10 years, maybe the phone, some 3G or 4G technology. Some of these technologies took time. But with respect to AI, I think the demand and the outcome is so significant. I have this feeling that we can adopt this in much faster pace, maybe 5-6 years. But we need to act now. And we need to have access to technology. Like I said, US has 25% of the IP that they developed in the recent years, and China is growing really fast. Japan is at 14%, but they probably don't have the talent pool in terms of numbers or the data we have. Perhaps we need to think of some innovative ways. Maybe we want to partner with some other countries to come with better technology that helps our local needs. And we are ready to, as Intel India, contribute to the ecosystem, be it in terms of accelerators or programmable compute, CPU, GPU, FPGA, you name it. We will be part of this revolution for population scale AI initiative. What worries us the most is the policy with respect to AI. There's so much talk about biases. When we infer things, it's a function of what we train on. And if we don't have our localized solution, our inferences are likely to have unintended biases in the solution. So we need to make sure we have our policy that just not addresses the security, safety, and privacy, but it also pays attention to the biases and ensures we are bias-free. And last but not the least, in terms of data, I believe we have the workforce that can meet the data requirements of the world. There's a lot of world outside AI in terms of collecting the data, curating, basically labeling the data, cleaning the data. And we can convert some of our workforce that can be the data engineers for the world and help drive this data exchange program across the industries or government or academia or anything to make sure data is the new oil. So we take advantage of that. We are a data-rich country and we are hungry to innovate. So if we can focus on these key vectors, I think we can really realize this dream of leapfrogging and making sure the entire population is uplifted with this population scale AI. With that, I'll end with this quote from our own Dhirubhai Ambani. If you don't build your dream, someone else will hire you to build theirs. Basically, we have been the talent for the world, and we have built our own technology, but we also have been building a lot of world's dreams. But we have enough challenges now. Perhaps we can tune a little bit more towards building our population scale AI goals and build our own dreams. Thank you very much for the opportunity. I'm here for any questions if you have time.
Thank you so much, Mr. Srinivas. It's very interesting to see how the ecosystem is coming together to solve this problem at the population level. I have a couple of questions that I got from audience. So first question is, we have heard of AI on X-ray solution for COVID testing, but this has not been in use so far that much. People are still relying on RT-PCR tests and other tests. Why is that world has not found a popular AI-based solution for COVID-19 so far?
That's an area a little bit outside my expertise, but I would think, like we talked about, AI is only as good as the data, is my personal view, data available. And the data is still very early and evolving and mutating too fast, I would assume. I don't know if this is the right answer. I think there's lots of advances. I read about it, but whether is it at the production scale where AI can be deployed to either diagnose or even project the trends and all. I'm not up to speed with all the technologies. I think it is growing, but I would still think this is an area that as the data pours in, this for the God forbid for the next pandemic or the remaining the tail end of the current pandemic, we will leverage AI even more significantly than I'm even aware of what is being used on. And research is going. I mean, at Intel India too, there are initiatives to to help these AI, to help some of this COVID research with AI, I can pass on to my my research team that can probably give better answer to that.
Sure, thank you. And there's one more question that I would pose to you. AI at population scale seems to be the need of India and China. Do you think innovation in this domain will come from these countries mainly?
I think it is necessary for us to innovate because, like we talked about it, India and China are the most populous countries in the world for one, and we have our unique problems. Be it in agriculture, education. Every country has their own DNA, and India has its huge uniqueness. And innovations, we can leverage innovations of the world where it makes sense, the global innovations and global technology. But we can't wait for the world to solve our problems because our problems are unique to us. So yes, I think innovation should come from us, and that helps us, and we can leapfrog some of these innovations to solve the world's problems in several cases. So it is not just a nice to have, it's a must have, because it is our unique localized problems and our own data that we need to focus on to create innovations that fit our population scale AI.
Thank you so much, Mr. Srinivas. It has been a delight to have you
as a
keynote speaker. And thank you so much for this interesting talk.
It's
okay. With that,